Okay, cool. Welcome back. We're on to the next module of computational mechanics. So next deadline is kind of like coming up into October, which already feels crazy that that's right around the corner. But here we are. And then after that, we'll work on project 2. Have you had a chance to look at module 2? Do you know what it's about? Not yet? That's okay. I know some people were working ahead. What is module 2? Module 1 was kind of like, get your feet wet, cut your teeth on Python. Like, get into it, use some Jupyter notebooks. What are we doing in module 2? What happens there? Analyzing data, yeah. So just, because roughly, like either you have experiments or you make big models, end up with a whole bunch of numbers, and then what do you do with that? So you can plot the numbers, you can put them into tables, you can do all sorts of stuff. But at the end of the day, you're trying to take something and like make a decision with it, or tell somebody that they're doing something right, something wrong. So that's kind of what we're doing in like analyzing data. So we'll do a couple of things. Like one is just like getting data into Python, and then you can work with it. Python's going to be a lot more powerful than just like using Excel. Like you can dump lots of data into Excel, and you can do very complicated and niche analyses in it, but it gets cumbersome really quickly, and it's very hard to figure out like how cells refer to each other. Python is a lot more reproducible, where you can show someone else either a Jupyter notebook or a script or a function that takes a set of data, does something to it, and actually see line by line what's happening. So first describing plotting, doing some statistics on it. Probably you have enough like stats background or knowledge that you know what we're trying to do, like mean, standard deviation. Something new might be like histograms and box plots, like how do you visualize a statistical number? And then last thing is like build our own models, like use some Monte Carlo models. And so Monte Carlo is a fancy way of saying like, I'm gonna throw some random numbers into this function and see what happens. We'll do all sorts of cool stuff like that. That's my quick intro to module 2. Any questions or issues? Anything broken yet? Not yet. Yes? Something's broken? What'd you break? Oh, for the project? Yeah. It did work. Okay. Yeah, as you're like kind of troubleshooting, so the new, we've used NumPy already, but Pandas is a new like library that is introduced in this module. And it's similar to NumPy, like it's structured data, but you can import a lot of different kinds of data into Pandas. NumPy is just kind of like, all right, here's a whole bunch of like floating point numbers, just like numbers with decimals, and it just stores that in a very predefined array. Pandas is sort of like, all right, here's some text stuff, here's some dates, there's some time values, and you can mix and match all these different data frames and like stuff like that. You can even have data frames full of like NumPy arrays. So if you ask for like row number 7 of column like vector, you could have a vector in every data spot. So we can kind of reimagine what, we're not going to do that, but lots of different possibilities. But I wanted to show like a little bit of mix of like classic coding versus like new age coding. So I have a CSV file, and in this case, I know where it's located. So there's some stuff that I already know how to do. And when I print out the first like 10 lines using head, so head is a Linux command that lets you see like what's the top of this file look like. There's also tail if you want to look at the bottom of the file. This is great if you don't want to look at like everything in the data in like this big CSV file, because here we can already see there's like 2,400 rows. So if I printed out the whole file, now I'm looking at 2,400 rows of stuff, right? And here I'm just printing out like 10 lines. So I know where the file is. I can take a look at it and see what it looks like. But then the question is like, how do I get Python to actually understand what this stuff is? So one way that I could do this is copy all this, just those first 10 lines. And okay, let's go. I need a pandas data frame to read this CSV file. Here are the first 10 lines. And we'll see what it comes up with. I didn't do much prompt engineering here, but just like a quick thing of like, I know I have a CSV. I know I want pandas. How do I connect the two? Because sometimes here's the data frame. All right, so here it's like, it's creating the data frame for us, which I don't know. I don't know how helpful that is. If the CSV file is called beers.csv, how do I load it into here we go. That's what I was looking for. So now it's giving me like a snippet of code of like, all right, this should, and it thinks that it should work, but we can try it. I think it will work since that is the line of code. Yeah, right there. So that is the code that is the next line of like load this into a data frame. But if you have data and you're like trying to figure out like, all right, how do I get this, or maybe like one of the columns is so here like if one of these columns was a date and time, you could ask like, how do I force column date to be a date time format? And then pandas, then this could give you like an extra piece of code to do that. And one of the first things we talked about in the class was like, ethically, what can you take? What do you need to like credit ChatGPT with? For one line of code, read CSV, I mean, there's not a lot we can do to say, and it's probably pulling it directly from the pandas like documentation anyway. Like you'll probably find that line with a different CSV file in there. But yeah, there, I don't know if I would say like you have to credit ChatGPT for that, because you're just sort of like getting information from it. If it's also like plotting the results and doing like more stuff, then maybe say like this is where that came from. But anyway, thought we would mix a little bit of modern and even Python's pretty modern coding, but now the process of coding is sort of like ask ChatGPT, paste it back in, ask ChatGPT. Okay, that was my quick. But as far as like if you're breaking stuff as you're like loading in data, that might be one way. It's like try pasting in just the top of the file and say, how do I read this? Or how do I mess with this, and how do I work with it? It's in this Beers CSV. It's 24. What was it? 2409. So there's like 2,409 beers in this like CSV. This is definitely not a big data problem. This is just like a data problem. There's data. The CSV file. Let's see. Coming into this data. Yeah, like this beer's CSV is 159 kilobytes. Like you can easily email it, or yeah, kilobytes is like nothing. You could probably paste it into the main part of the email. Just people wouldn't read it. Not that they read your emails anyway, or anybody. Not that anybody reads emails these days anyway. You just have ChatGPT summarize emails for you. Like, what do I need to do today?
How do we see like the whole graph? So I see small section.
Oh, like see every line.
Yeah, it's just like the first five, last five, and then like I just do other 24.
Yeah, like if you want to print.
Like if I want to just like look through it, like cause like so like in that line you just like you print that data frame and then boom it's just the top.
All right, so once we have like beers, I'm gonna zoom out a little bit. So once we loaded in that data frame, shows us the first 5 and the last 5. So we get like 10. And the question is like, how do I see everything? Because we're in like pandas and Jupyter work nicely together, you can like rearrange them by name and start seeing like different, but it's still just showing you, I think 10 total. But we can say, all right, I could look up the documentation, but we'll be like modern engineers, and how do I force pandas to show every row of a data frame in Jupyter? Yeah, display max rows. That's it. I'm gonna say 50. Wait, what? None. That's what it told me to do. Yeah, now it shows me every single row. And it does, like, it's not bad because it's in like a collapsible like output cell, so you can kind of scroll up and down. But yeah, if you do want to pick through each and every, or if you want to go down to a certain row, like why is this brown ale like a 0.095? Is that alcohol? That seems high. Yeah, that was ABV. Anyway, yeah. But yeah, that was the main trick. Is this display dot max rows? Set it to none, and then it'll. I'm also gonna look at, because I don't know why it didn't work for. I don't know why it didn't work for like a different number. Oh, you can say that it's equal to something. And also kind of mixing like documentation and ChatGPT. Like sometimes ChatGPT will give you like a line of code, and if you search that line of code, it'll get you into the right spot in that documentation. And that's a nice way to like close the loop of like, where's it getting? Like, how does it know that? And usually it's because there's lots of open source information that informed how ChatGPT is like creating that code for you. But what I was trying to figure out is how do you set it back to the original? There we go. You can set it back to 10. And a little different pd.options.display.max rows rather. At least that's what Panda's documentation had it as. But it worked as set option. That one worked too.
Actually, no, it comes in at 19.2.
So we were playing around, as I was kind of walking around, playing around with a couple of things, mostly around like indexing, like how do you get certain things out of your data? Like roughly I know what I want, but how do I find it? So one of the questions was like, what if I what if I don't want like just the last 5? What if I want to see the last 10? Like how do I grab those values? And like if this was a NumPy data frame, like NumPy array, then I would say like -10 colon to say give me the last 10. So start at the end of the file, but go backwards 10 steps, and then show me the rest. And then ask for every column, so all the last 10 rows and every column. But in this is because it's a pandas data frame, it doesn't default, there's no default like numerical indexing like that. So instead I'll say dot iloc, and now I can index it just like I would a NumPy array. So that was one thing that we were kind of looking at. And then from there, like if I wanted to index, usually it's easier to index things by the actual column names. So I could say like dot loc I think this will work. There we go. So I can give it a list of like what column names I want and what rows I want. Oh, it didn't work. No. Right? Because it didn't give me the last 10. It just showed me everything. Do I need iloc? Yeah. Oh, that didn't work. What's going on? All right, anyway. But I can give it like a list of if I give it a list of column names, then I can kind of separate down like just the stuff that I wanted. And then I guess I would say like .iloc or something. Anyway, I could, but it like subsets, it creates like a smaller data frame where I'm indexing just what I wanted. And then the other question was kind of like, how do I grab things that I want to see, like certain numbers that I want to see, like all the IBUs that are above 50 or something, or like I just want to see what's happening when IBU is above 50. So I could grab like beer. Well, first let's do this. Beers of IBU, and it just gives me like a whole bunch of stuff. More than 50. And now I have a whole bunch of, right now all I see is false because it's a whole bunch of things. But I'm only looking at the first 5 and the last 5. But if I have true false arrays, I can plug that into my actual like pandas data frame. When it's true, it gives me that row, and when it's false, it throws the row away. And now everything that gets printed out is something that has, and how big is it? 468 rows. So let's do like over, I want to see like the extreme 120. A bitter bitch. Yeah, so there's only like 4 beers that are over 120 IBU, and they're all American double imperial, or one of them's an American IPA, but mostly imperial IPAs, like really high IBU stuff. But that one's a pretty useful, as you're trying to like play around with the data of like, how do I just look at certain things, just the last few values, or just values that are extreme or really small, or what are the values that I'm throwing out, like what are all those NANs? And all of this is part of what's called like data exploration. You're just sort of exploring, like you're not trying to tell a story yet, you're just trying to figure out like, what are the connections? Where's this data coming from? What does it mean? What do I want to say about it? And do I trust it? That's more the process here of like, how do you trust and what do you know about your data? Then from there, ask like a mathematician or a statistician, like, hey, can you do some fancy stuff for this? And they're like, yay! Yeah, and sometimes it's like just a kernel connection shows like you were connected to a kernel, but it went to Steam or something. So yeah,
what's the ideal baby? Pressurize and build it. This is what the this was up for beta distance. So the most meter is already so 4 times. Swear, just need to know. Some a lot of Americans
Do one more inside thing. Just to, so you take your, so basically you take your different. Yeah, so basically it takes your data frame, it converts them to a NumPy array, or stub values, and then it cleans it by, I think so, yeah. Yeah, I definitely did that. I did it in 2 steps. Yeah, but the brewery you want to pay
But if you look up this number,
then you just take the line. So your data values, it's total number. And your total series. You subtract it from your divided by your
non-available things, so there is no equivalent between like NAN and so instead there's special functions called isNAN. This is NAN or is NAN. Oh yeah, yeah. Yeah, like we've already used it. Yeah. Sometimes it's, especially if you're learning stuff, it's nice to like see it how it's working. How is it supposed to work? And then
All right, another good question came up. Like when you have an object that is an NaN, so like some of these rows or some of these values are missing in our Beers data set. I think even just printing out first 5, last 5, like especially the IBU is missing from a lot of Beers because it just doesn't get measured in a lot of stuff. Like usually IPAs do measure the IBU, but stuff like English brown ales, like they just don't bother with IBU measurements sometimes. So the question was like, if I say NaN equals NaN, that should be true, right? Like I should be able to look for cases when NaN equals NaN. But the problem is that's false, because an NaN is saying like it's not available. So something not being available, it's not necessarily equal to something else that's just not available. And I'm kind of justifying this. I think that this probably should work. I feel like there should be a hack to make this work, but instead we have other functions that are like is NA and is NaN to look for true and false statements. So rather than saying like is that equal to something else, I would write np dot is n. Yeah, so for NumPy it's is nan, but for Beers it's is NA. So if you're trying to figure out like which of these are NaNs, it fills up the whole table with true and false statements. And so is NA is, and again, I would love to like rewrite some of this stuff and just like, if we're gonna use NA, just is NA all the time. But again, there's a lot of people involved. So there's is nan for NumPy, is NA for pandas. But I could write like this IB if I want to look for the number of NAs in that IBU column. I could grab just that column. So I'm just saying Beers of IBU is NA. How do I find how many true statements there are? Do you know? How do you count the number of trues? Do you know what? Sorry? You could use an if statement, yeah.
Yep. You just like sum them up, so true is just equal to 1.
So true is stored as the number 1, and false is the number 0. So if you sum it, then that gives you the number of true statements. So np dot sum of all of those says that there's 1,000 NaNs in that IBU column. And like there's more than one way to do this. You could also like clear all the rows that have an NA and then compare the length before and after. But again, in this data exploration phase, just kind of looking around, seeing what works, what you trust. And then can I use that one? Yeah, that works. I think the squiggle, the tilde, gives you the not true. Yeah, so if you use like a little tilde at the beginning, that like I use it for home directory in my Linux exploration, but that changes all the falses to trues and trues to false. Yeah. Yeah. Yeah.
So in your notebooks, you have this dotted line that runs down.
Yeah.
This one is the easy way. If you print it, it wraps itself.
That's what I thought at first, but it seems like that's not the case. I think that one's giving you like I think this is 80 characters.
And so it's still, if you were to print it or print preview, it wouldn't wrap it.
No,
It just shows that this is what needs to be cut off, basically.
Yeah. Well, it's not that it would cut off there. I think for
PEP8. Let me double check this. PEP8 line with 79 characters. There's like in Python, if you're writing code and you're submitting it to be part of the open source like Python project, their recommendation is never more than 79 characters. And that's what that, I'm pretty sure that's what that dotted dash line is in this Jupyter notebook.
How do you set that up?
How do you set it up?
Yeah, because I've done Jupyter notebooks outside of this class and it doesn't have the
That one, yeah, that is a good question. How did that get in there?
Did you set it up in the main environment?
No, because this is set up through like NanoHub.
Maybe they used to do it for you.
Yeah. Header, cell. Widgets. I don't remember. I know I've seen it before, and yeah. Anyway,
That's fine.
yeah, it's a good question. I don't know how to turn that like on and off.
It's fine. Just it's helpful to know that it's there because then otherwise previewing it starts cutting it off on the page.
yeah.
Thank you.
Time flies. You're like having fun with data.
Cool. That's it for today. Enjoy the weekend. Maybe go try some of the beers and make sure that they exist. And then on Monday we'll be back. Try something else.